Good everyone, my name is Graphics. In this video, we'll be talking about dimensioning. Dimension is an important attribute in drawing, right? And we have two types of dimension. We have the size dimension and the location dimension. Now let's look at the size dimension. Now one thing you need to understand is your size dimension can be of two types. We have the change dimension and the datum dimension. For instance, I want to measure the distance from here to here, from here to here, from here to here, right? I'll take a datum, that is a starting point. Let's say the baseline here is my datum here. I will ensure that my line is not touching my diagram and I'll thicken it. You can see that? Now, the next thing I'm going to do here is that I'll be taking reference from each point, right? We're talking about the datum dimension now. I'll take reference. So from here, I can say that from this point to this point, right? From the next point to the next point, and from this to this. Now, if you wonder what I'm doing, we're taking a reference point here. They have the same reference point. So the first one here is I'll take in here. I'll go to the next one. I'll do the same thing here too. I'll go to the next one. I'll do the same thing here too. Right? And I'll put my arrow. The arrow should be as sharp as possible. You can see that? Now I'll say that from here to here, it will be on top of the line, not below, but on top, and must not touch the line. So this will be, we know this is from here to here is 20. Then from here to here is 40. It should be at the middle. Then from here to here is what? Is 60. Right? So this kind of dimensioning is called what? The datum dimension. I can also do the same thing for what? For the horizontal line here, right? We're taking a reference point. Now let's now look the different type also, which we call what? The chain dimension. Now if I want to do that of the chain dimensioning, right? I will come here, I'll do the same thing. I will take a reference line this way, right? And I will take my line upward this way to stop here, right? And here, ensure that your line is not touching your diagram from this point straight to this point. You can see that, and you must avoid your line cutting out from your main line here. So this from here, we have this, and from here we have this. So from this point, I'll cut it out. From this point, I'll also cut it out. Make this out a little bit. You can see that. Now from here is this. From here is this. And we have this. And then this. You can see that. I'll now start writing. Here should be 20, 20, 20. Right? So this is what we call what? The chain what? Dimensioning. And this is what we call what? The datum dimensioning. You see, these have one reference line and these have a line, but they are related to another. So one thing you need to know about the datum dimension is that what? It has an advantage, right? The advantage is that the size measured is independently from one edge, and consequently error are not cumulative. That means if I should make mistake from the first measurement here, it doesn't affect the dimension from here to here. doesn't affect dimension from here to here because they are all independent of each other. But in terms of what of the change dimension, they are dependent upon each other, right? Now, if from here to here is 20 and I make a mistake and I went to measure 10, it is going to subsequently affect the next measurement. It will affect the next measurement, right? So this is the disadvantage of the chain over the datum, right? In the chain, we have a cumulative error. In the dimension, we don't have a cumulative error. Is that okay now? Now we move forward. Now, from this same diagram here, your dimensioning can be, there are different ways at which you can place your dimensioning. The way I've placed it now, we'll call it what? The aligned system of what? Of dimensioning. This is what? The aligned system of dimensioning. Is that the key now? So under the size dimension, we have what is called the chain dimension and that dimension, which can subsequently be the aligned system of dimension. This is what? They are all aligned, right? Now, we move forward. And most times, let me assume that I have a circle here, right? And I want to locate my circle. So we say we have size dimensioning and we have what? Location dimensioning. So in terms of circle, we call it what? Location dimensioning. So let me assume that my circle is here, right? Let me say I have a circle at this point here. And I want to measure the distance of the circle. Now what I'll just do is, at this point, I won't allow my diagram, I can just bring it out a little bit. Right from this point, I can just do it this way. And I'll come here to do the same thing here. And it must be at the center of the circle. So from here to here, and from here to here, then I'm going to write what I want to write. Let's see, distance is what? Is 30. Right? So this is what we call what? A location dimensioning. Always involve a circle. You focus on the center of the circle and you take a dimensioning, right? And we'll move to the on-directional system of what? Of dimensioning. So let me replicate this diagram down here. On-directional, this is what we call aligned system, right? So let's see the on-directional here. The same thing, using the same thing here, right? Then I'm going to take the same measurement here. Right? So the first one is from here to here. The next one is from here to here. And this. So now you know here it is 20. It is wrong for you to write the 20 in a vertical manner. How are you going to write the 20? You're going to write the 20 in this manner. So this will be, the 20 will just be in this manner here. 20. Here will be 40. Here will be 60. Right? So this is what we call what? The on-directional system of what? Of measurement here. Right? Now the next one, the same thing will apply here too. So if I'm doing that in this case here, now that means I'll be leaving space in between, right? This is the what we call the on-directional what system of what of dimensioning, right? So now another thing we should look at is if I want to dimension this circle here, right? And I want to dimension the circle by using a leader line. What I'll just do is I will draw a line from this point that will go through. You can see that, and I'll put my arrow here this way. Then I'm going to do this here, right? So put my diameter, whatever it is. Let's say it is what 20. So this is when you dimension using what a leader line, right? And now let's take this one last example and see how we can apply all what we've learned. So let's see how this will go. So this is what we have here, right? Now I want to measure, this is what we call a fillet. That's what we call a chamfer, right? Now, if I want to dimension a fillet here, what we'll do, there are two ways I can do it. I can just from here, draw a line that will go through it this way and draw my line like this, right? Then I'm going to write it out there. Say radius what? Using radius 15, right? We use radius 15 here. You can do it that way too. Then the next one is to do this. You can actually do this by, and I want to measure here. So I can just do this way. An opening, just draw a line here and also a line here, right? And this way and this way. I see that? And the distance there is just 5, right? So there are different ways I can actually write it there. I can write it anywhere. Maybe I can put it here 5, right? As I told you, I'll put here 5, I can put it here. Let's say 5 millimeter, just put 5. Depending on how you want to put it, right? And for the chamfer, I can easily just measure from here to this point. Then from here also to this point, right? So we're having this and this. So from here to here, this is the 15. Then we have here 15. You put your arrow. So this is what we have here for this video. So if you have found this video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.